All right, let's begin. To my Twitch viewers out there, I apologize for not streaming the past couple of sessions. Again, work's become really busy, and I've been in the office more often, trying to get stuff done. Things are getting hectic. Juggling between 4 projects right now with pretty closely knit deadlines, so that's really slowing me down with everything else I want to do. And then I actually ended up working in the office over Saturday on one of the projects to help move it along a little faster. So that's where I've been. That's where the videos have been. Why I haven't been streaming, just trying to catch up with work and too many real life things going on. So we're back at it. I do appreciate you hanging out with me today. Sticking with this series, I really do appreciate that. To our YouTube viewers, thanks for checking out another video. I know it's the upload schedule's kind of broken up, but again, that's just due to my full-time job just picking up with work and juggling schedules and just not really having the chance in the evenings to upload videos. I know I could schedule them, but that's sometimes just too much of a pain to try to get all that managed on top of all the other stuff I've got going. So I typically will stream and then upload a video, a priorly streamed video to YouTube the same time. So that's pretty much why there haven't been any new uploads. So to get back at it, we were working on the sub project, the fan tester. And if I recall right, we were almost done with it, but kind of decided to add a power control system so that the fans are not powered up by default. That way, if you go to unhook and connect and disconnect, you're not gonna run the risk of getting your fingers kind of involved in a fan blade. So what we're going to do is I went ahead and sourced and updated the system for a little MOSFET. This little guy right here. It more than enough, a little SOT 23, 2 amp, capable, 60 volts. So this guy is more than enough to handle it. Relatively low cost for its capabilities. I already use it in other projects, so there's no reason not to use it here. Again, sometimes the best thing you can do is stay as modular as possible and reuse parts everywhere you can, because it simplifies your BOMs, it simplifies your inventory, and just everything else. So I've already created it in here. So let's go in here and go to components. It's a Q. All right, MOSFET. All right. So fortunately, we need 3 of them, 1 for each power channel. Let's see what we got for resistor. So we want a series resistor. All right, let's see. Let's see, 100 ohms. 120 ohms should be fine. Ah, 0805. That's a little bit overkill for this. Let's see here. We don't have a simple 100 ohm or 50 ohm resistor in here. So one of the things with MOSFETs is when you're driving the gates, you don't want to drive them, they're voltage-based devices, not really current-based devices. So we want to have a resistor to kind of help limit the current. And typically 100 ohms is more than enough. So let's go and find a 100 ohm resistor. I didn't think we needed one. I thought we already had one, but that's my fault. So let's go ahead and find a resistor. Passive components, resistor. So I'll just drag this here. So we need a chip resistor. We're just going to go ahead and 100 ohms. All right. Case code 0603. No reason to go too terribly small with this. So now it just comes about availability and price. 15 cents, not bad. Pretty good stock on that. 15 cents. Let's see if we can find maybe like a 10-cent part, like a Yagio. Pretty good stock on that. If we really, Yagio, we got Vichy, but we'll just go ahead and go with the Yagio because let's see what's its bulk price. Actually, when you start getting into the higher bulk prices, 100, you start getting better pricing. Reel of 10,000. Their reel's only 5,000. So actually a reel of these guys would be cheaper in the long run. Well, let's see here. Let's look. Oh, full reel of 10,000 is $50. Full reel of 5,000 is $80. Yeah, okay. So you get much higher quantity. Your price breaks get better off the Vichy part. Oh, let's see. Does the Yagio part have? Oh, even the tariff's even higher on the Yagio part, which is kind of ridiculous. So yeah, all right. So we'll just go with the Vichy part. They have a good quantity, even though you get better price breaks. The more you buy. So that's what we're going to choose. So let's get the Kaikai. We don't need a footprint because it's an 0603. Let's go to symbol editor. Components. So here's something I'm going to do. We are going to copy this. We're going to paste it. Oh. Why don't you copy? There we go. All right, so let's get in here and I'll show you what we're going to do. File, before we get too far, symbol name. Oh. All right, so what we are going to do is we are creating a template part that way. All right, and get rid of that. We're going to save it. So what I've been doing is making my life a little easier in both Ultium Designer and Circuit Studio by creating template parts. I don't have to try to keep the parameters. We're gonna copy this. We're gonna copy, paste symbol. Okay, so now here we go. We have the symbol properties. So we are going to grab our naming, RC0603. Let me find my naming convention. RC0603. Our value is 100R. R. Boom, 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 boom. Our tolerance is 5%. So that is AAD. And then our voltage on this guy is 75 volts, 0.75, and it is 100 milliwatts, so that is 0.0. Okay, so we're going to go ahead and save it. Come up to here. We're just going to copy this jive. All right, there we are. So we got the resistor. File properties. All right. R 100 ohm 0603. Oh, actually, I need to go in here. This is 0603. Yeah. Okay. 0603. Description. Let's go and make our life a little easier. Let's properties. Hundred ohms, 75 volts, 5%, 55 to 155. Rojas, not Q200. Alrighty then, manufacturer one. Grab this stuff. Grab this information. Volume. My volume. We consider 1,000, so. There's another one we're going to put in here. Just kind of like leave that star for now. Okay. Okay, we're going to show reference and the value. All right. Let's see. So that's our 100 ohm resistor. But before I get too far ahead, we need to throw this into our products, unfortunately, in Odo. That way I don't have to worry about it later. Let's see, was it 19 cents? That way it's done. When I go to create the bill of materials, everything will be there. Mausa. All right, so that's there. That's there. Save that. Go back to our schematic. All right, so now we should be able to add the new resistor that we added. All right, there we go. 100 ohms. Boop. Okay, so we should be okay using the single resistor to drive all three of these, because again, we're not really going to be using a lot of current, so that should be fine. So we're going to put these on the high side. Let's get this stuff dragged out of the way. That way we can kind of grab all this stuff, drag it down as far as we can. All right. All right, So what we're going to, yeah, I keep forgetting, each of these programs is different. Get rid of these. All right, since that's there, that would be the source. Check gate. Stop. Yeah, just kind of drag that there, that way. Okay, so. Lining things up so they look a little bit better. All right, so there we go. Bloop. 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 Here. Oh, so, let's kind of take these guys over here. Stop. Okay. Just have to keep getting used to this. Then let's just give that that label. Boop. Power control. Now what we're going to do is that should work. And here too. Make it a little bit easier to read. All right. So that should do. We have our power control off the ESP32. So, you know what? What we should do is 10K. 10K. This way we have a pull down resistor to make sure the gates all do stay low. That way, there's no gray areas, or we try to limit the gray areas. That way any outside influence doesn't accidentally trigger one of the gates. This resistor may be subject to change. I'm not, we'll have to test just to make sure. I'm going to have to drop the diode to like 50 ohms. Maybe even just a standard pulse resistor, something like a 10 ohm, just current limiting, but we'll see. We'll see what kind of performance we get. But, that may change, but we'll find out through testing. All right, so we've got that guy. All right, so the more I look at this, the more I'm thinking we should throw a few test points in, and it never hurts. Even if we never populate them. All right, components. I think they're under connectors. Yeah. Even if we never populate them, I think they're valuable to have. Because you'll still have the holes that you can solder into. In the board. Again, so if you... Oh. All right. Oh. Okay. Yeah. Getting a little crowded, but I think we're okay. I'm not going to... For what this is, I'm not going to be overly concerned about how crowded this is looking. All right. That's the LCD connection. Okay. All right. I think we're okay here. Fan connections. Let's go ahead. Throw in... fan tack. Let's see here. All right. Let's kind of this all cleaned up. At least a couple of test points. Let's just throw another one down here. That way you can kind of group these together. Again, even if we don't populate them, we'll still have the test points. We'll have access to easier to grab test points, so we can just solder some through wires or hold a scope probe to or whatever. All right. That way we can group this with these guys. That way we can at least look at the power control, the tack. You know what? We should throw one for the fan PWM. Oops. And PWM. That's fine. Because the VCCs you can pull off of these jumpers right here. That's not a problem. You have easy to access test points for that. It's not a problem. All right. Okay. Right. So, Fantac. Got that. All right. Okay, all right. Our primary power supplies. All right. Oh yeah, I said that's a barrel jack. Almost forgot to what we were designing with. It's been so long. Let's go close this. Go here. Let's get the PCB opened up. Let's start our layout. Okay, here we go. So, all right. So let's see here. It's cuts. So that is our board. Right now, this is 2 layers. Might be more than enough for what we're trying to do. Maybe. Although a multi-layer board, a 4-layer board with a large ground plane does help add stability. So let's go to the layer stack. Here we go. We got it. You gotta figure out all this again. Like I said, I don't use this guy enough. There's a layer stack. No. Really? Don't tell me it's actually done here. No, should be in here. Oh, great. I gotta figure this out again where the layer stacks are. Seriously. Yeah, Kaikagi are just not intuitive at all. We need to use the layer stack manager. Is it under preferences? It's not. Oh my god. Do I seriously have to Google how to change how to handle board setup maybe? There we go. Physical copper layers. Jesus Christ. 4. All right. Okay. Okay, copper. Copper. All right. So I want to okay. File. Board setup. All right. Power plane. Power plane. Okay. There we go. Now okay. So let's make sure we're on our edge cuts. And I guess we just start kind of line down. Oh. All right, so just okay. Well, let's see here. All right. Now update PC from schematics. Update. Close. All right. Drop all you guys right there. All right. Okay, so it looks like the boards have to be a little bit bigger, but that's fine. To figure out how to set up the nets. All right. 3.3 layers. Okay, can we do that in here? Figure out how to set your net. Something just feels completely wrong with this. Those are big switches. 3D. Oh yeah, those are some big switches. Oh yeah. It's okay though. That's perfect. Perfect. And that's fine. A little bit of a bigger board is a happy board in a case like this. So okay, so we'll definitely have to readjust our all right, so we'll fix everything. We'll fix the border lines once we get that all done. All right, so we have that. We have our power jack. So we got to kind of figure out how we want things to come into this guy. So like the power coming from the back side, which makes sense. Our switches would be like, you know, like right over here or something. Right now we're just gonna kind of candy sprinkle this. We'll fix all this. We'll figure it all out. So we're gonna candy sprinkle the primary components, like the important stuff, like kind of like the buttons. Don't even really need the ESP32 in that mix right now. That's one of the fan connectors. So let's see here. Let's just assume that somebody's like, you know, let's say maybe off of that side. That's a fan connector. That's the SMT fan connector. Then, yeah, that's the Molex fan connector. All right. So we're kind of like looking at that. Okay. So we're kind of, oh, hold on. And then, hold on. No, let me make sure I have the right one, because one's not the fan, one's the, CN1 is the fan connector. So, okay. That's the fan connector. This is the LCD connector. That's going to be not terribly, that'll come into play depending on the enclosure and how we're going to have all this mounted. The next thing is, after looking at this, thinking about it, we might want some mounting hardware. We might want to go ahead and throw some on here. I'm not sure yet. But if we do, we'll have to figure out where we want that. Right. Okay, we got some test points. We got the MOSFETs to control this stuff. You stop. Okay. 1s and 3s. Those are our voltage regulators, our power regs. So we want the supply stuff to kind of hang around the power supply. Get the big Schottky diode we'll want here. Maybe the power supply stuff kind of hanging around over here. Again, we're going to, you know, bring the size up. We'll make everything bigger as we need to with the PCB outline. Just trying to get things kind of, the candy sprinkles in here so we can kind of get an idea how we want it to look. So let's see here, our switches. We have the 2 push buttons. Oops. The 2, you actually selected for me. There we go. We have the 2 little tiny push buttons, and that's for the boot mode and reset and everything. Really? All right, KiCad, let's stop. There we go. That's for like boot mode and the enable on this guy. Again, FTDI header for programming rather than the USB UART, because the very simple singular purpose device, no reason to not use just a UART header with an FTDI cable. So we have that guy. Okay, that can, the ESP32 stuff can kind of be tucked, back here or center or something. LCD candle. That'll be for the display. The primary things we want to kind of look at is like the connectors for the fans. We want them easy to access. The buttons to be easy to access, and everything to have a logical sense to it. All right, these are our power selections. We want those to be in a nice logical place. And then we have the LEDs associated with them. These guys. Yeah, so we'll probably end up double-siding this just to make it a little bit easier. That way the size doesn't have to be extremely high or extremely large. And I still think we can pull it off in 4-layer versus 6-layer. I just need to figure out how to define those power planes, those inner layers, and I just don't understand why I can't do that. Why I can't tell it what this layer is. Yeah, I don't know why KiCad doesn't make things that intuitive. I shouldn't have to jump through 1,000 different menus just to try to figure one little thing out. And honestly, I do find this extremely annoying. Because in Circuit Studio, I can just get in, right click on it, tell it what it is, and boom, I'm done. I'm not fighting it. It's defined as the power plane. It's defined as the ground plane. I can tell what net it's applied to, and I'm not fighting it. I'm not trying to jump through a bunch of different menus. So yeah, I do find this rather annoying and frustrating. So yeah, I don't like it. Same thing with Altium. I want to be able to just right click on it and tell it, hey, I want to assign you to the ground net. And then I want to assign you to the 3v3 net. How hard is that? I just don't understand. It's baffling. Why I have to jump through menus and hoops and stuff when it's a plane. There's nothing special about it. So I find it extremely frustrating. So to continue our shotgunning or candy sprinkles shotgunning, we may want these guys. I know everything's kind of just haphazard right now, but maybe, I kind of like the top-down approach. I kind of like that. Again, it's just candy sprinkles while we try to figure out how we actually want it to lay down on the board, just to kind of get an idea of our footprint. So this guy is one of the power supply ICs. Tend to want to kind of keep them all kind of grouped together to make life a little bit easier. The ESP32 can kind of just sit down here then. In a section like this, the LCD display. Again, we're going to have a 3D printed case, so you can kind of go like that. I don't really care. FTDI can kind of be like right, this guy. Our switches for boot mode and all that can kind of be up here. Fine by me. A lot of these are like the support components. They can go on the bottom. So that's one thing we'll do is we'll go ahead and double side this. So let's make sure. Let's go to the schematics. Where are our fiducials? Yeah, this is kind of getting noisy. Oh, root. Okay. There we go. So we got our fiducials. Let's go back to the PCBs. So that way we can bottom side it or bottom place stuff too. Fiducials. All right. Yeah, those are far away like that. What in the world are you doing to me? So these guys are... No, see, that doesn't help at all. Backside bump. And then we'll have to think, do we want to be able to... So if we're going to 3D print a case for this, we could do something similar to what we did for the stepper controller box. We might want to be able to pull something like that off. And I can't speak today. It's just been an extremely exhausting week. So I was thinking that maybe we could do it like the stepper controller board and use standoffs to mount like the upper lid to. We'll have to figure that out, how we want to go about doing that. Because I also want to make sure we have a nice safe spot to mount the LCD to. Since this is definitely have to grow in size to accommodate for some of these components, I think having screw holes to mount like the stepper controller board wouldn't be a bad idea. Let's try to think. Because we can always use like clips and just clip onto the side of the PCB and just have everything mounted through the case using standoffs and stuff. That way we don't take up any board space with mounting hardware. It's always a tough guess on how to do things like this. Because do we do it, do we use mounting hardware or do we just use like clips and other methods to hold the board into like an enclosure? Yeah, I like using enclosures for boards because it just, especially when you have through-hole components, it just really reduces the chances that you're going to short this poor little guy out on a work surface. Like you have a stray wire trimmings or something, and you're going to short something out. I've seen that happen, so I really like enclosures for stuff, just to protect it, to keep that from happening. So let's kind of go from the idea of using like body clips for this. Let's kind of go with that idea. So I'm not going to set onto the board outline right now the way it is. Let's kind of get this guy all nice and set up. We'll kind of start with the switches, the buttons, the oversized the man buttons, I guess, or whatever you want to call them. I don't care. So let's see here. So that's a reset. So switch 1 is a reset. All right, so if that's a reset, how do we want to go about handling that in the order we want these guys in? So increment, decrement, we definitely want them. And the other one's test. Start, stop. Actually, what we're going to do is just switch the order. All right, so switch 2 is up and switch 3 is down. Let's add. We'll put the reset kind of off to the side. I mean, we got kind of room. That's kind of like a test. No. Okay, hold on. I'm getting myself confused here. Okay. 2 and 3 increment and decrement. Okay. Okay, no, I didn't. Test 4 is test control. And switch 1 is okay. All right. Reset. Kind of push this guy off to the side. I don't know if we absolutely need it, but we'll go ahead and keep it there for now. Now, one of the things we could do, we can really mess with reset. Increment. And control. Let's see here. Let's see here. Oh, you won't let me do that? Oh. Oh. Okay, KiCad. Don't need the number after it. Jeez Louise, KiCad. Does this make it mad? 3 reset switch. Okay, no, I don't care. Okay. They're big switches, so we have plenty of space underneath their main body for the... Yeah, as long as we don't pull over, have to re-update the PCB. Maybe we can always fix it later. I don't care. All right, so I want enough room between these guys to, you know, I don't want anybody to have to struggle to connect or disconnect something. That's always horrible. You don't want to have to struggle to connect, because when you have to struggle, especially with an SMT part like this, that's when you start ripping parts off and you start tearing pads. I want to have enough room, I want to keep it clean and neat, but I don't want anybody to have to struggle trying to reach around and work around other components to make the connections. I want everything as clean and clear as possible. I have to look at the actual part for this to see where the through hole. So that's a little through hole for that component for an indexing key. That's on the part itself for an index. To help when you install the part, it lines up, pin 1 properly. I want to see what side of the part that's on because I may have to rotate that. I'll double check that. Okay. These guys, sure, so they can go in the back. There's like an easier way to do that. Oh well. Again, I shouldn't really complain too much for a free software package. Okay. So these guys are associated with these controls right there. Okay, these are TVS diodes. Honestly, they can go on the bottom. All right, those guys can go on the bottom. And I'll drag them to where they need to go because these guys are big through-hole parts. So we'll be able to get those tied together pretty neatly. Pretty cool. All right. The ports. Here, so is there like what we got here? Okay. Panels. Properties. I mean, that kind of does that. Oh, okay. Well, maybe. All right. A lot of these resistors, they can also go on to the. All right. Okay. All right. That makes life a little easier. Come on. They go with. Where do they go? DC. Go again. Wrong key combination. All right. Yeah. So they go with the buttons. This guy goes with this guy. Okay. Okay. So it's just a matter of taking our candy sprinkles and getting things organized, getting a game plan together. Yeah, so I think that's what I'll do. Because what we'll do, because remember, this guy right here, that's just an outline I threw in here to get things kind of started. It'll have to get cleaned up. Okay, this makes life a little bit easier. Where is 0? Can I? Let's go to tracks. Drag this guy down. Not tracks. Other right? All items? What in the world are you? Layer edge cuts. You're a line. Oh, well, I'm not going to complain too much. All right. So let's say can I Breadboard? All right. All right, all right. That's what I was looking for. Okay. Okay. Okay, okay, okay. Makes me happy. So now I got an origin there. All right. Move you out of the way. Kind of start with some of these shotgun parts here. Let's get this off. I keep calling it shotgun. That's another term because, you know, like it's scatter shot candy sprinkles I try to use to not be so... All right, so I like this. All right, so if we're not going to use any mounting hardware, okay. All right, all right, all right. Okay, I want to make sure I have enough room for one. I don't know. Can I hide that stuff? Yeah, excluded from bill of material. Oh, I like that. Okay. Don't need that. Can I? Oh, yeah. Okay. Hide that. Hide that. Okay, that is probably assembly or something. I don't care. All right. Okay, so this pink right here is the courtyard. Okay. Yep. So that's fine. I have a fiducial kind of in a place like that. Two. That. I don't care. All right. Oh, no. Zero. There we go. I like it. There we go. That's going to help a lot. All right. So now we have that going for us. Pull this guy up. Preferably above that. No. 5 and 10. Let's use that. Okay. Yeah, okay. But we can at least do that. Yeah, there we go. Okay. Oops, forgot to grab footprint. Boom. All right. Sometimes it's hard to jump back into another program after using Altium all week. Oh, all right. So let's say Y is up and down, so 10 millimeters. Oh, beautiful. And let's worry about, okay. 30. I like this. I like going by the numbers to organize this stuff here. 75. All right. Hello. I still don't mind the larger text. Can I tell it? Yeah, I don't like, yeah. Angel. All right. So that is 15 millimeters. So grab this, and then boom. There we go. There we go. All right. Okay. Perfect. All right. Well, it's already been an hour, and this is going to take some time. So, just like with the other board PCB layout, we will get back to this in the next video, the next stream, which, to be honest, probably will not be tomorrow due to how busy it is getting at work. But I will definitely try. If I can, we'll stream tomorrow. If not, we might just have to try to shift our, deal with the schedule as it is and, deal with what we can. I thank you for hanging out with me and checking out the video. Hanging out and watching me fumble my way through this, through my exhaustedness due to all this stuff that is going on at work and everything. So I appreciate it. Thank you, and have a great rest of your afternoon.